Hey everyone, good morning. Great to be here. I know this is the session I'm standing between you and lunch, so hopefully this will be useful for you all. My name is Pranav, and with me is my colleague Kunal, who will be up very, very quickly as well. And then both of us work in the Web3 team for Google Cloud. A lot of people get surprised, firstly, seeing Google at a Web3 event, and then again, seeing Google in a ZK event. So I'm going to share a bit more about what we do in Web3. We've been very, very active in this space. We've been investing in this space since almost last 6 to 7 years. So I'm going to share that. And then we'll also talk about how we are working with several ZK companies in this room, outside this room, in terms of helping them scale their infrastructure and scale for the next billion users. And we do this because as a company, we have a lot of experience in building products which have billion plus users. So be it like Google Cloud, Google like YouTube, Google Search, Google Maps, each of those have a billion plus users. So that has given us extensive experience of building infrastructure at that scale, right? So I'll give you some sense of what we've been doing in the Web3 space overall as Alphabet, which is the parent company for Google. So on the top right is Google Cloud, which is basically at the forefront of our Web3 strategy. We are building very specific Web3 products. Like we have a dedicated product team which has launched a RPC service. So we have the most generous free tier of Ethereum RPC today. We index 30 plus blockchains to make the data very easily accessible. We are also building specific node infrastructure and node management products as well. So that's what our Web3 team is doing within Google Cloud from a product perspective. We are also one of the few large Fortune 5 companies that accept crypto payments. We do crypto transactions. We have crypto in our treasury. So we're very, very bullish on this overall space as well. Then I think very relevant for this event is we have a research arm called as Core Labs. And there we have a team working purely on ZK research and cryptographic research, not just for blockchains, but also to identify other ZK applications like for identity, for devices, and for privacy aspects as well. Along with Core Labs and Google Cloud, we hosted the first ever ZK Summit organized at our headquarters in the Bay Area earlier this year, where we had like 100 plus researchers and Web3 companies come together. As Google Cloud, we also lead a lot of partnerships in this ecosystem. So I think that's a way for us to have a skin in the game and also have actual experience in running blockchain networks. So we actively run validators in several networks like Polygon, Solana, Aptos, Foundation. One of my colleagues, Deep, here basically leads that team which is running validators as well. So that gives us first-hand experience of running blockchain networks itself. We are also one of the largest corporate investors in the Web3 space. So we invest in companies like Fireblocks because we really believe in the whole security of the Web3 space. We also invest in companies like Yuga Labs, which is the parent company for the Bored Apes, right? So that gives you a sense of how DJ and Google overall is. So that's to give you a sense of how committed we are in this space. We've been building in this space for the last 6, 7 years now and actively work with several Web3 companies. Like I said, the kind of products we are building as Google Cloud, which are very, very Web3 specific, is basically we are sticking to our expertise in building scalable, secure, planet scale infrastructure. So that's what we want to bring to Web3 as well. So we're building Web3 specific products, infrastructure products like RPC services. We launched Validator as a service, several node offering products as well. We launched our Web3 portal, which is where we have our Ethereum faucet, and that faucet today is the #1 ETH faucet. We get almost 20 to 30,000 developers per day come and get testnet tokens for Holsky and Sepolia. It's the #1 Ethereum faucet today, so that we're very proud of that as well. We do a lot of things around blockchain analytics, like indexing 30 plus chains. Based on all these efforts, we have seen a lot of traction from the market. So several leading companies in the Web3 space are building with us. So be it protocols like Polygon, Aptos, Solana, Berachain, Phantom, they are fully with Google Cloud, and we do a variety of things with them. A lot of exchanges like Binance, Coinbase work with us. Again, when it comes to topics like AI, security, compliance, these are topics where we very actively work with exchanges. We also work very actively with, let's say, companies which are building tools for Web3 like Nansen and Chainlink. So across the various segments of Web3, we have seen massive validation and traction of these leading players picking and working with Google and Google Cloud, right? Given we are talking about ZK, so I think most of the leading ZK companies are again very actively working with Google Cloud. We have Polygon, we have Polyhedra, we have ZK Sync, we have Tycho, Starkware. They're fully on GCP as well, and we have an active participation helping them scale their ZK infrastructure, their prover infrastructure very closely together as well. Now, what does Google do in the space of zero knowledge? So this will help you get some sense of what exactly we're doing. The three pillars: we do a lot of research, we help scale infrastructure, and we're building the overall ecosystem of this early stage space, right? So from a research perspective, our labs team is focused on investing in basically like new proof systems. So specifically topics around sum checks and those techniques are very interesting for us, and in exploring a variety of use cases. So they've been exploring use cases for, again, identity systems of running ZK on devices as well. From an infra perspective, Google Cloud basically helps accelerate a lot of these ZK proving systems, either using CPUs or GPUs or even TPUs in some cases as well. We also help in simplifying the management. So I think it's one thing to scale, but scaling with simplicity is something which we are very strong at, and that's what we bring to the Web3 companies and ZK companies as well. So exploring unique architectures of Kubernetes, which is what my colleague Kunal will also briefly talk about. Then we also bring in the best-in-class Web2 security to these ZK networks, right? And then overall helping them optimize the performance. From an ecosystem building perspective, like I said, we organized a ZK Summit along with a research arm. It was a very curated event at our headquarters, first time that we did this year, where we brought in leading researchers like Dr. Dan Bonet, and we brought in leading companies in the Web3 space together, like a very small, cozy group of 100 people together at our headquarters as well, right? Now, before I hand over to Kunal, I want to give you a sense of how we are helping scale the infrastructure and hopefully build the next billion users. So this is from Coinbase. So this is a broad overview of the ZK infrastructure landscape. So at the bottommost layer is infrastructure, where you have companies like Ingonyama working on hardware acceleration. You have ZK VM companies like Succinct and RIS0. You have a lot of proof networks. You have Gevulot outside over there as well. Then you have a lot of networks on top of it, which are basically, let's say, privacy-focused L1s, or you have ZK EVMs. And then you have the application layer. So the way Google looks at this is basically there are two sides of the equation. There's the demand side, which is the application, and then there's the supply side, which is the companies creating the ZK infrastructure. So we see a lot of innovation happening on the bottom two layers in terms of on the supply side by reducing the ZK cost and the platform cost, and we see innovation happening on the demand side to create that demand, right? So we focus a lot on the bottom two layer, working across these variety of companies to help them reduce the overall platform cost as well. And I now hand over to Kunal, who will share a bit more about how we are doing that.
Hey, folks. So what I want to focus on is really just share some learnings with you. For the last 6 months, we've been working with a customer to operationalize a zero-knowledge proving platform. And just want to share those learnings with you. Couple of things to keep in mind is that we're talking predominantly validity proofs, not talking about fraud or challenge proofs. And the second piece is that it's a game developer chain, so you can imagine that the throughput is quite significant that we're dealing with. So when we talk about platforms, what are the two things or what are the two considerations that we're taking into account? One is the roll-up maturity roadmap. And why we talk about that is that it really just gives you the timeline in terms of what is that maturity timeline for the roll-up to be fully decentralized. The second piece is the type of proofs. Most of the chains that we deal with, you would say that they are fully EVM compatible. And what that means is that we are talking about type 1 proofs. And unfortunately, that means that those generating proofs for those that workload, it's quite compute intensive, it's quite usage heavy. Going on to the rollups itself, just by design, rollups are all about throughput, right? So not only are we dealing with a heavy compute workload, we're also dealing with heavy throughput. To make it even more challenging, especially in a gaming environment, depending on the time of the day, if certain games are very popular or not, if new games are being released, that sort of also dictates a lot on the demand that is put on the chain. So the throughput itself is quite unpredictable, to say the least. So you've got this challenge of having unpredictable workload and a heavy compute usage. And what that means is that the proving platform, the biggest challenge becomes the cost, being able to manage that cost. What we also saw when Pranav sort of highlighted the various landscape that we are dealing with, various tool chains that we have to use in our ZK proving platform, the challenge is that it's such a ever-evolving sort of landscape. How do you actually make a choice today and not sort of shoot yourself in the foot or sort of box yourself into a corner? So what we have actually thought about here is that we have taken a layered approach to this problem by trying to abstract away the technology that we will use in terms of zero-knowledge proofs that we will use. So at the top layer, you'll see the orchestration layer. No, that's not going to work. All right. So at the top layer, you'll see the orchestration layer. All that orchestration layer, think of it as a smart logic that does everything from splitting up the incoming request to parallelize the request processing. It can do so that it can submit proof generation to multiple workers, like things like that. It aggregates that request. It will do basic error handling and sort of even monitor things or measure metrics to make sure that it's keeping up with the tip of the chain, right? Like you don't want to lag too far behind. So those pieces. The second part of the second layer, that's actually the proving, whatever proving framework we use. If it's ZK EVM, if it's ZK VM, you can plug it in there. And the basic difference there essentially is just that with ZK EVM, you're writing specialized circuits and designing specialized circuits, right? Whereas with ZK VM, it's just a generalized VM, and you essentially write any Rust code through it. And the third one is the hardware layer. So if your proving platform uses any specialized hardware like GPUs and stuff, then that's where you can plug that in. So what does this really look like? I was completely seeing the wrong, showing you guys the wrong slide here. I was actually talking to this slide. I was just watching it on here. So hopefully somebody can repeat all I've said and you can think about this slide. But just to sort of recap it, it's the orchestration layer is at the top. The layer 2, which is the circuits, is the second. That's your proving, whichever proving framework that you use. And then the last one is the hardware layer. Okay, and this is the rough architecture that we have that we are running with. This is like if you think of this is the standard flow, this is the happy flow. You've got requests coming in from the RPC client. That request gets to the orchestrator. Orchestrator does basic level of state management, so it keeps metadata around the proof. For example, just to make sure that it keeps metadata on the block to make sure that it's not reprocessing the same block again and again, or if there is failure, it will maintain that part as well. Then it submits the request to the leader. The leader is responsible for splitting that request, or if it's a block, it will split it into multiple transactions that can be processed in parallel. It will aggregate that proof, and then once that proof gets verified, it can update the state. So that's a very, very simple happy flow there. The magic here really is in that orchestrator layer. So you'll see is that orchestrator is quite flexible. I've got to say that it's not a product or anything like that. That's something that we have implemented for a customer. And what you'll see here is that it's a simple retry logic here. Right, so you've got a request that is coming in. The first thing you'll do is that you'll check your state database and see if you've already processed that block. If you haven't processed that block, then it will just send it to leader and it will follow the happy path. But if you have seen, if there is an error generated while you're generating proof for that block, the error will go back to the orchestrator, and the orchestrator will then check if should I actually send this request back to the same network, or do I switch over to a different network? So it actually allows you to be that traffic director to send request to some other proofs. And this is like the exception handling, or the how do you handle exceptions. So again, the request comes into the orchestrator, the proof is generated, and while proof is being generated, you find an error. I'll talk a bit more about what that error could be. But then you've got that error going back. You write that back to the proofs, or you write the state back saying that I actually found an error while working with this proof. Then the decision that needs to be made is that, do we actually just expand, or do we actually horizontally scale the proving network, or do I need to send this proof generation request to some other network? That's something that can be taken care of by orchestrator again. And the real simplicity here is that none of this is actually doing any state management, right? And what I mean by that is that the arrows that you see here, those integration points, there is no state managed in there. What that allows us to do is that it just allows us to use underlying Kubernetes as that scaling mechanism. There is nothing else that we need to do here. I said that I'll talk a little bit about the errors itself. There are two types of errors that we need to be really mindful about. One is just the operational error, right? Like basic system faults and things like that you just can't do anything about. Out of memory errors, that type of things. And the really important or critical one is actually a DDoS type of error. So if there is a malicious actor that has found an operational code that has a really, really low gas price, but it's very, very hard to prove, right? So, and if they start flooding the network with that type of request, you essentially start lagging behind your tip of the chain, right? So that's the type of DDoS attack that we also need to deal with. And what I will end on is I've shared a very, very, very high-level view with you today. We've collected some very, very interesting metrics when we did this engagement. Our partner BCW, they were very helpful with this engagement. Some of the basic things, so before I started this project, all I thought about was the number of transactions in a block. That would be the most important factor. But as we went through the exercise, it's actually the gas. How much is the block filled in terms of gas? That's probably the most important metric that we need to think about. So it's things like that. That was a good learning curve for us. But really the call to action here is that if you guys are doing any of this exercise, we would love to talk to you. Would love to have a discussion around that. So yeah, please come and talk to Pranav or catch us afterwards. Thank you.
Thank you. Guys, Google is ready for 1 billion users for ZK. Are you ready? Any questions? Okay, please.
Yeah, so thank you for the presentation. I have one question. If we assume that computation will become almost free, let's say at some point, with innovations in hardware, etc., have you thought about other primitives aside from zero-knowledge proofs like MPC or FHE, where bottlenecks are not computational only, at least, but also bandwidth? Because you also charge on bandwidth if bandwidth is like really high, and these protocols require that to happen. So have you done any assessment towards these, like maybe future directions?
Definitely not from a technical standpoint. Like I'm sure there is someone with a really good spreadsheet that is doing that work. But the basic thing I think still remains the same, right? Like if you look at it as a technical challenge, finding that technology at the right time and being able to swap that technology in and out, that's probably more important than choosing the right. Because if you wait to choose the right technology, as the saying goes, you'll wait forever, right? You need to make that start today. That's where the critical problem I think we are trying to solve.
Thank you.
Thank you. I have a question about the last picture. So what does that service actually do? Is that like a blockchain round? The last picture, so there's a statistics data about something that this one.
Oh, sorry.
So what exactly this picture is about? So what's the service does it do? I mean, the business service, what does it do?
Yeah, so this is just a dashboard that is created for executives to give them a view of how the system is performing, how many proofs are generated, and what sort of gas is used, and how does that translate into dollars. So this is really just a metrics, a SQL database that has been a benchmark data that we have collected that we will use and create dashboard for it. So now it's not a blockchain.
Yeah, and I think where the use case of this is to what Kunal said. So if you want to take a specific ZK technology and run it on multiple machine types, run different scenarios, this is where we have a benchmarking as a service, and this is the final output of it. So we ran a bunch of provers on a variety of machine types, on a variety of techniques, like parallel versus sequential, to get some sense of cost estimation.
Great. Actually, I'm curious if some of the existing Google products can actually adopt or utilize ZK technology.
So we've been exploring that for some of our products on the devices side. Yeah, I think that's what I can share right now. But it's a very important area for us to see how ZK can help some of our existing Google products, which is why we have a dedicated research team working on this space.
Please share with us more at our future events. Okay, thank you guys.